Okay, we are going to do quadratics in standard form. Now, because last week we learned vertex form. Do you remember that? Remember the vertex form was the one with the brackets? Remember? Just don't write this down, but remember if I gave you something like this, y equals x minus 2 squared plus 3, you should be able to tell me right away what the vertex is. What number do you plug in here to make that thing 0? 2, comma, 3. What's the vertex? 2, comma, 3, right? That's vertex form. Okay, now, we are going to learn standard form, and standard form is as follows. What's f of x mean? It means y, right? So it's going to have an x squared, an x, and then a number, right? What makes it a quadratic is the x squared. Because is y equal x squared? Is that a quadratic? Y equals x squared. Yes, it is. It's a standard quadratic. The parabola goes through the 0, 0, the origin. Looks like a, remember we graphed those last week, the standard ones? And all these other things do things, move it around, right? We move it left or right, we move it up or down. We open. If it's negative, it flips it upside down. Okay, so let's look here. Summary of the effects of A, B, and C on the parabola. If A is greater than 1, so if the number in front of the x squared is greater than 1, what does it do to the parabola? It makes it narrow. Is that correct? Remember if it was like 2x squared or 3x squared or 4x squared, it makes it really narrow. The bigger the number, the narrower it is. Okay? What if it's between 0 and 1? Like if a half x squared or a third x squared or a quarter x squared, what does it make it do? Makes it wide, right? It's compressed vertically and what's wider? What if it's less than 0? Basically, what does it mean when it's less than 0? What does that actually mean? It's negative, right? I mean, we talked about that in math. When you see something, hey, A is less than 0, it means it's negative. And it opens down. Oh, how do you remember? Min or max? I can't remember that. Mountain max. Remember mountain max? So if it's a mountain, is that a maximum? And the other one is a minimum. Just remember mountain max, Cassidy. Mountain max. It is, but I'm just, some people logic doesn't apply, right? You have to kind of give them rules. I'm telling them. Yeah, okay. Okay, so now, if it's in standard form, you look at that, you can't really tell what the vertex is. So we have a little formula. Now the vertex is made up of what? Two things. X and Y. Okay, if we know X, we can actually just plug it into the formula and figure out what Y is, right? Standard thing. So we need to know what X is. Well, there's a nice little formula to do that. You can always find the X coordinate of the vertex by plugging in this thing. Negative B over 2A. Do you have to memorize this? No. Is it on your formula sheets? Yes. If you want to find X, negative B over 2A. And it's easy, because as long as it's in standard form, do you know what B is? That's whatever is in front of the single variable. And do you know what A is? It's whatever is in front of the square. Simple. We'll do an example right away. Well, here, do you have room on that page? Yeah, let's just make one up here. Let's do it here. Y equals 2x squared minus 4x plus 3. There it is. Let's look at this. This is a quadratic because it has an x squared. Is it in standard form? Do we have an x squared, an x, and a number? Now, again, we don't have. You could have this whole back piece missing as long as you have an x squared. Okay. We want to know the x value of the vertex. So how do we find the x value? What is it again? Negative b over 2a. Okay, now, what's b? Negative 4. What happens when we make it negative? It now becomes positive. So it's 4 over, what's a? 2. What's 4 over 4? Okay, so the x value of the vertex is 1. Right? How do we find the y one? Take x and plug it into the equation, right? That's all you do. Can we do this? I bet you we can do this in our head. What's 1 squared?
1.
Times 2?
2.
Minus 4. So 2 minus 4 is? 2 minus 4 is? Negative 2 plus 3 is? 1. Okay. So what is the vertex for this thing? 1, comma 1. Well, that's tough, isn't it? Why is it useful to know the vertex? Well, that's where it changes direction, right? Either mountain or mint. Now, first off, is this open, up, or down, by the way? Up, it's positive. What's the vertex? That. I bet you I can even tell you the y-intercept without looking at it. Hey, what's the value? Think about where a line crosses the y-axis, right? It's called the y-intercept, right? Wherever it crosses the y-axis. What's the value of x where it crosses the y-axis? 0. What's that? 0, 0. What's the y-intercept? 3. Well, you now know the vertex that it opens up and the y-intercept. Could you sketch that out? Yeah, pretty easy, actually, to sketch that out, isn't it? So standard form is useful because, first off, in standard form, you know that guy right away. Okay, let's do the first example. Flip the page. There we go. These windows here, this is for your calculator here, but I'm going to show you how to do this manually. So for the graph of the quadratic below, and here's the quadratic right here, negative x squared plus 2x plus 8, right? We're going to do a couple of things. We're going to sketch it out. We're going to tell me the direction of the opening, the vertex, max or min, axis of symmetry, x and y intercepts, domain and range. Standard question. You got to list all this junk. Once you know some of it, the rest of it's really, really easy. Okay, so let's look at this for starters. Negative x squared. So does it open up or down? Opens down. So we're going to have a maximum, right? Could you tell me right away what the y-intercept is? 0, comma 8. Could we figure out the vertex? We know we have the formula, right? Negative b over 2a. Could we do that? Yeah, let's do some of this work. Okay. So how much room you got on the page? Oh, you got lots of room on that page. Okay, let's do a couple things. So y equals negative x squared plus 2x plus 8. Okay, so let's figure out, we know the y, what did we say the y-intercept was? The y-intercept, oops, I'm just writing some of the stuff down that's useful to me. Y-intercept is 0, comma 8. Okay, let's figure out the vertex. X equals negative b over 2a. Okay, what's negative b? That's a, that's b, that's c. So what's b? 2 becomes negative 2. What's a? Careful. What's a? Negative 1. Right? Don't mess up on that negative. There's negative. There's a 1 between that x and that negative. Right? I guess I should fix that so you can actually read that. So negative 1. Okay. Negative 2 over negative 2, which is positive or negative? Positive. Negative divided by negative is positive. Come on, guys. Well, that's only one part of the vertex, isn't it? What else do we need? What do we need? The y value. Don't we need the y value? But how do we find the y value? Plug it into the original equation. Well, that's easy. So, can we do it manually? Let's do all the work here, just so you have it in your notes. So negative 1 squared plus 2 times 1 plus 8. Is that correct? 1 squared is 1, negative plus 2, positive 1, plus 8 is 9. So what's the vertex? Vertex is 1, comma 9. Yes? Steps to find the what, the y of the vertex? All I did was took the original equation, this guy here, and wherever I saw an x, what did I replace it with? A 1. So 1 squared, right? Which is 1, make it negative, plus 2, so negative 1 plus 2 is positive 1, plus 8 is positive 9. Right, all I'm doing is substitution. Now here's the interesting thing. You now have enough information to answer every single one of those questions, other than the x-intercepts, which we'll talk about in a minute, which is something coming up. So let's graph this thing. Now, obviously, is the graph right above there? But let's graph it manually. And when I say graph it, I'm not actually talking about, oh, let's make a nice, beautiful little graph with little tick marks. We're talking about a sketch, right? And the sketch can be without tick marks as long as you tell me the key points. What would be the key points that you tell me in this graph? The vertex and the y-intercept and possibly the x-intercepts if we could find them, which is actually coming up a little bit later, but we'll do this. Okay, so let's sketch it up. So we'll just make, I'm doing a basic sketch, so I need a y, which is not straight, I need an x. Whoa, whoa, the board's out of control. Maybe it's just the feature. Okay, there it is then. It opens down. What's our max? What's our vertex, sorry? 1 and 9, so somewhere right about there. What's our x-intercept? That's right, let me rephrase that. What's our y-intercept? No, 8. Y-intercept. Look, y-intercept. 8. Okay? So basically when you draw it, does it look like that? Yeah? And you label the key points, right? You label the key points 1, 9. Here is 0, 8. Well, I guess it would be useful to know those x-intercepts, wouldn't it? We'll talk about those in a minute. Well, let's answer some of the excuse me. Let's answer some of the questions. What's the direction of the opening? How are these labeled? These questions? I should actually have my notes in front of me. I don't have to look. So the graph. This is A. The graph opens downward. Is that correct? Downward. B is asked, what's the vertex? Well, we did that one already. What is the vertex? 1, 9. C. Max or min? Okay, now, you could say max, right? But you normally have to tell me what the max is. But how do you write that? You don't just say max equals 9. What value is 9? It's the y value, isn't it? So max, you go y equals 9. You have to put it in that form. You need to tell me that you know that the max is the y value. Okay? I'm being really picky about this, but this is the way we do stuff. What was the next one? Oh, okay. D, the equation for the axis of symmetry. Now, if you notice, it says equation for the axis of symmetry. So you don't just put a number, you have to put a letter there with it too. Now, we have the vertex, so do we know the axis of symmetry? What is the vertical line that this thing flips around? 1. Isn't it x equals 1? Right? Flips either left or right around that. So the axis of symmetry is x equals 1. That's the equation of the axis of symmetry. Don't just put 1. I don't want to see that. I need the equation. Whatever the middle line is, whatever it flips around. X and y intercepts. We know the y-intercept. What was it? Oh yeah, the y-intercept is 0, 8. Or you put y-intercept equals 8. I'd accept both of those in that case. We'll do the x's in a minute. Domain range. This is F, right? Domain. Let's do domain. Domain is what? X or y? I can't remember. X. Alphabetically, right? D, R, X, Y. Now think about this for a minute. We're talking about the x values. That arrow is going on forever. Negative infinity to positive infinity. 2 ways of writing it. You could write it either with round brackets, negative infinity to positive infinity, or what's the other way? Do you remember? Yeah, fancy brackets. X is all real numbers. Is that correct? That's the fancy way of writing it. That means x, you're basically defining the variable first. X is the variable and it's a break. It's like a period in a sentence. Right? We're breaking it up. We're just saying x is our first variable. Because what happens is you can actually define them as a set of variables. You can do x comma y, and then your single slash. Let's do range. Now range is a little bit trickier. The most common mistake I see for range they spin the direction around. You always start with the positive or the negative. Which one? The negative. You always start with the far left for domain and the bottom for range. So what's way down there? Negative infinity comes all the way up to what point? What's the maximum y value? 9. Does it include 9? Yes, it does. Okay, so negative infinity to 9, but includes 9. The most common mistake that I see is those two flipped around. Is that correct? Yeah, that's the most common mistake I see in that case. Or instead of a square bracket, they'll put a round bracket. Why do we put a square bracket? Because it includes that point. Okay, what would it be is the fancy way? Y is less than or equal to 9, less than or equal to 9, and y is an element of R. Right? It means it's all a real number, which means all the decimals and fractions and all that stuff in between. Do those make a little more sense now that you've seen them from last week? The two different types, interval and roster notation? Get used to seeing them both. Okay, now, let's talk about x-intercepts. I'm not too stressed about the x-intercepts right now because we're going to do a whole big old lesson on x-intercepts. The x-intercepts have a bunch of names. What's the other one? Roots, zeros, x-intercepts, roots. Those are common names. Basically what we're looking for is, we're looking for where they cross the x-axis. Now the interesting thing is, what's the value of y where they cross the x-axis? 0. So could we take the equation, make y equal to 0, and solve for x? Okay, well let's just look at that for starters and see if you can even do that. So here's the original equation, y equals negative x squared plus 2x plus 8. Is that correct? And we made y equal to what? 0. 0 equal, oh boy. Have you done these before? You actually have. Well, I know you have. You actually have all done this before. You just don't remember it. Do you remember factoring? Remember grade 10? Do you remember factoring? First thing you always look at is you take out what's called a GCF. Do you remember GCF? Greatest common factor. What's our greatest common factor in this case? No, it's not a 2. You can't take a 2 out of there. Take a 2 out of both those, but you can't take it out of the first one. Negative 1. You always try to take out your negatives because we always want our A in front of here to be positive when we do this. Okay, let's try that. Like I said, don't stress if you don't get this because we're going to do a whole big lesson on this one. So 0 equals negative 1. Okay, now let's do this. Negative x squared divided by negative 1 is just x squared. Positive 2x divided by negative 1 is minus 2x. Positive 8 divided by negative 1 is minus 8. Okay, so we basically took out a negative number. Now the reason we did that is we have this thing here. In fact, I see 3 terms. 3 terms, that should be familiar. What's a 3-term polynomial called? What's it called? A trinomial. Oh! We used to do something to trinomials. We used to factor them into what? 2 binomials. Do you remember that? Oh, let's see if we can factor this guy. Let's just take a wild stab at it and let's see if we can do it. Bet you we can. Okay, so when you're factoring a trinomial into 2 binomials, I always got my students in grade 10 to do it specifically this way. First off, write your brackets in. Put in all the easy stuff, right? If you put in the easy stuff, the hard stuff doesn't seem as hard. Okay? What times what gives us x squared? X and x. So that's easy. It's not bad. So all we're missing now are some numbers and some signs. So what you do is you look at the far right-hand side, and you look at that sign there, and you find out the sign is negative. We know from the past that if the sign is negative, that the 2 signs within the binomial are different. That's what it means. So with a positive, it means they're both the same, and then you look at the in front of this number and you put both those in. But because it's a negative, it means the signs are different. So one's positive, one's negative. Okay? So we have to figure out the order of them. Now, we look at 8. We look at all the factors of 8. 1 and 8 and 2 and 4. Guys, 95% of the time, do you guys remember rainbow trees? Do you remember doing the rainbows? Sorry, the rainbows? Yeah. Remember, if we did this, don't write this down, right? 1 and 8 and 2 and 4. Guess what? 95% of the time, it's the two middle numbers. I'm just giving you some rules to remember. Okay. So it's 2 and 4, isn't it? Okay, now look here. So we put in a 2. Does it matter the order yet? No. Now look here. We want this 2 here to be negative. So which one of those has to be negative? The smaller one or the bigger one? The bigger one, right? That's the way it works. So negative and positive. Okay? Like I said, don't worry, we're going to be doing a whole big thing on this. Now, we still haven't solved for x yet, have we? But what does x equal? Or sorry, what does the answer equal? 0. Watch. Watch, I want to show you something. So 0, we don't care about the negative one because it really has no bearing on this whatsoever. There's one of them. 0 equals x minus 4. Well, can you solve those now? Of course you can. Just move it to the other side of the equal sign. You move the positive to the other side of the equal sign, it becomes what? Negative 2 equals x. Over here, 4 equals x. Guess what we just found? 2 x-intercepts, didn't we? So go back to your original equation. Go back to your original graph and look here for a sec. Now, I know we sketched this. But what's this number here on the left? Negative 2. What's this number here on the right? 4. We can write that in. So 4, comma 0, negative 2, comma 0. This bottom part here, solving for x, we're going to spend 3 chapters on this stuff alone. Because what's going to happen is they're eventually not going to get very nice looking. These are nice numbers, aren't they? We're going to start dealing with radicals. But I'm going to teach you something called the quadratic formula. Let me get to sing it in class, and there's a little movie that goes with it. Oh, trust me, you'll love it. Now, like I said, this bottom part, don't stress too much about it because this is coming up. Okay? Now, so let's take out a calculator. Let's look at the next question. This is something, if you were taking applied math, this would be a common question you'd see in applied math. The introduction and the pre-cal is they want you to do some of this with technology. The problem is does everybody have technology? No. Right? If you want to do this, you can go online. I have calculators online. You can try this one. If you got a frog, he's sitting on a rock. Sounds like a song. Right? The rock is above the water. Right? Rock is above the water. Water's down there. So the frog jumps. Frogs jump in guess what shape? Perfect parabolas. Wow, cool, eh? Did you know frogs jump in perfect parabolas? They all went to math school and they learned how to jump in parabolas, right? When a frog jumps, it's a perfect parabola. Is that true, by the way? So the frog jumps off this rock, goes up a bit, does a little bit of hang time up there, right? Then lands in the water. What's the problem? And it's actually modeled by the function negative 490t squared plus 150t plus 25. That's really annoying that that's on the second line, isn't it? Is it on yours? Oh, yeah, it is. Oh, that's horrible. Okay. Now, in reality, would this be just nasty to graph by hand? First off, it's negative, so it opens down. The problem is the numbers, right? All right. So what we're going to do is we're going to do this on the TI-83. So if you don't have one, you can just follow along. I'll throw it up on the board here, which I do, if I could remember where I put it. Hang on, let me find it. It's on my bar someplace. Where's my TI-83? On there? No. Somehow it's disappeared off my bar.
Oh, what is wrong with it?
Yeah, I'll find it in a sec. Give me a sec. TI... Sorry, what? I can't remember. I think I left it as a program, though. That's the only thing. Yeah, it's going to come up as TI Inspire. That's why. Hang on. I brought the whole file over with me. Hang on. Give me 1 sec. T3 Tarsia, Tina, Smart. Where is it? Virtual Calc. That's why. VTI. By the way, if you want a copy of this for at home, just bring me a flash drive without a virus on it, please. And I'll give you a copy of this. Okay, so this is the calculator here. So I don't know have you guys used these calculators before at all? So you go to the basic one you want because this is a graphing calculator. Up in the top left-hand side here is y equals. Basically what you want to do is you want to put the formula in there. Okay, so our formula is negative. Now please make sure there is a difference between negative and subtract. Do you see the difference on the screen? Negative is the little tiny guy, subtract is the bigger guy. We want the little guy to start with. So negative 490. Oh no, I can't put a t in there, but can I put an x in? Yeah, so you use all those variables here. It's x, t, theta, and n. Just basically your variable. Squared plus 150 x plus 25. Okay. Now, if I hit graph right now, are we going to be able to see it? Probably not. Because what happens is you always got to set your window, and your window are your dimensions of your x, the negative x to the positive x, the negative y to the positive y. A standard window on this calculator is negative 10 to positive 10, negative 10 to positive 10. That's a standard window. So if you want to set it as a standard window, let's go to Zoom and set it to standard. This is going to reset it all to negative 10, positive 10, negative 10, positive 10. I'm going to hit enter and let's see if we can actually see it. So it does its thing. Well, that really it didn't help us at all. Now, think about this for a minute. This is where actually common sense kicks in. Okay, hang on a sec. It's negative 10 to positive 10. A frog is jumping. Did he have a hang time of about 10 seconds? He's up in the air. And then goes down. No, is that the way it works? So what's the hang time of a frog here? Less than a second? So our x values probably have to be in like 0.1, 0.2, probably like up to maybe 1. It's a parabola, right? But you can't see it. The parabola is in there, but it's scrunched. It's really small and scrunched. Okay, so that doesn't help us. So let's change our window settings. So we're going to change our window settings, and if you look, there's our x min right there and our x max. So we're going to change this to -1, -1, and our max is going to be +1, which I got to hit delete here, so it gets rid of that. So basically what I've done is I've taken it, instead of from -10 to +10, it's now -1 to +1. So it should basically take our parabola and stretch it a bit so we can see it. Let's take a look. Hit graph. Oh, a little better, right? But what can't we see? We can't see the vertex. It's a little bit higher. So which one's that? Y max or Y min? What is it? Y max. Okay, so let's go back to window settings, and let's increase our Y max to, let's try 50. Let's see what it looks like. And there it is there. I don't know what's that other line on there? I don't know. Oh, it just did the 50. Okay. Is that manageable? Can we actually see that? Okay. Now, if you think about this, it's weird because some of the parabola is in the negative x, isn't it? Way over here. No, that doesn't make any sense. Can the frog go back in time? Last time I checked, this is not a time-traveling frog, right? Can you have negative time? No. So, but this doesn't make any sense to me then. What's going on here? So he jumped from the y-axis, right? So he jumped from this point here, the y-intercept, right? Went up a bit and then came down, and the x-intercept happens to be where it lands in the water. Is that correct? Oh. Now, according to this, if we look at this, does anybody want to take a guess, without ever doing any calculations, what they think the y-intercept might be? Take a look back here for a second. Hang on. What was the y-intercept here? 8. Isn't that right? If it's in standard form, can you look at the last number and see what the y-intercept is? Okay, so in this case, what is the y-intercept? 25. So what does that mean? The frog, he's sitting on the rock, and how far is the rock above the water? 25 centimeters, right? This is in centimeters, isn't it? Yeah, centimeters. So the rock is 25 centimeters above it. So he's going to jump. So is his vertex going to be above 25? Obviously. Okay, so now, we can do this. How do we figure out what the vertex is? Well, the calculator is really easy to do this with. Under trace, if you go to second trace, there's a whole bunch of things. Oh, zeros. Well, that might be useful. Is this a min or a max, by the way? It's maximum, right? Mountain max. So what we can do is we can go down here, we can pick max. Right? You pick max. And now what it was is it wants to find our boundaries. Basically, it wants to know somewhere where the left side is, where the right side is, so then it can find the max. The left side is anywhere along this line. So that's easy. So you just hit enter. Now if the calculator is smart enough, it should automatically kick over. Oh, no, now it wants to know the right bound. So I got to move my arrow somewhere over to the right-hand side at least. It could be anywhere over there. It doesn't matter. Hit enter again. And for some reason, this calculator was set up this way. It would always ask for a guess first. Basically, you could ignore it and just hit enter again if you want. But we know the y value should be larger than 25, shouldn't it? And our x value should be somewhere between 0 and 1, right? Well, let's see. When we hit enter, what do we get? The maximum is 0.15, right? That's the x value, so 0.15 of a second. How high is he? 36.4. Okay, that's cool. So our vertex in this case is, what was it, 0.15 and 36 point, what was it again? 0.48. Okay, we'll go to 2 decimal places on both. Let's try this again in the same color. 0.15 and 36 point, what was it again? No, 2 decimal places I want. 48. Thank you. Round correctly, guys. Good. Yeah? Is that useful to know? Here's the cool thing. If you have that calculator, can you do any one of these questions on your calculator? To check your answer. Because if I give you this on the test, am I going to give you, do I want you to do it manually? Yes, of course. Now, could you figure this one out manually? Could you figure out the vertex manually with that formula? This one right here, the one that's on the board. What do you have to use? Negative b over 2a. Would that give you the x value? Then could you plug it in and would it give you the y value? Okay, now, here's the hard part though. Can you factor that thing? That's a trinomial. Can you factor that into 2 binomials? No. Because you haven't learned it yet. That's the quadratic formula, which is coming up. That's the one I'm going to teach you in the next unit. So could you technically do this question manually at the current stage right now? No, you could probably do about half of it. Will you be able to do this after spring break?
Sure.
Yes, you will. You'll be able to do this question entirely manually. But could you use your calculator to check your answers?
Yeah.
Yes, you can. It's wonderful to do it. Okay, so, you know what? I don't really care about the rest of this because you're not going to do it electronically right now. But I'll show you how to do this later if you want. Let's go to the third one so we don't run out of time. This one I think we can do. Oh yeah, this is a great example. Oh, if you took applied with Mr. Slater, you've done questions like this before. Now we're going to approach it from an algebra point of view. You got a rancher. He has 100 meters of fencing. What? Fence. Put a fence up so dogs stay in the yard, people don't get in. Around your house. Do you have a fence around your house? Okay. Fencing, okay. He's building a rectangular corral, right? So 4 sides to this thing. We're going to keep some animals in there. Or students, whatever you want. Okay. So what we want to do is we want to make a quadratic function that represents this, because we want to know how big this pen should be to maximize the area, right? Because we want the animals in there to have the biggest area possible, don't we? Right? We don't want something like a fence like a meter wide by something really long, right? Because then they just run back and forth, right? We want a big, big area. Okay. Lanes. Okay, my goodness. Okay, so we got to define some things first. So what is area? What is area? Length times width. Isn't that correct? Length times width. You know that basic formula for a rectangle. So what does W equal again? Width. Okay. So here's the thing. Here's the thing that's different. The problem is you don't know what the length is and you don't know what the width is. That's two unknowns. You can't do that. You haven't learned to do that yet with two unknowns. Systems of equations, which we're going to get into again, right? You did in grade 10 a bit, but we're going to get into some more complex ones in grade 11. But here's the question. Can I define length somehow with the W in there? This is tricky. Basically, I don't want L and W. I want to be able to replace L with some form of W, because then obviously I have W's and W's. I can solve it, right? Okay, now think about what this looks like. We said it's a rectangle. Is that correct? Right? Rectangle. There's a rectangle. Okay, so here's the width. And what's over here? A width. Okay, what's our maximum that we have? 100, right? Our maximum is 100. We can't go over 100. Now, somehow I wanted to find the length. No, I want to define this. I want the length down here and the length up here not to be defined with an L, but to be defined with a W. Well, sometimes the easiest way to figure this out is put some numbers in. Okay, let's pretend the width is 10. 10? What would this width be over here on the right-hand side? 10. So what's the maximum that the length would be in total? 10 here and 10 here. How much do we have? 100. So what does the length have to be? 80, but it's split between two of them. So what would the length be up the top here? 40 and 40. Okay, that works. Okay, now we've got to create a formula. Let's try another one. 20 and 20. Let's pretend the width was 20. This would be 20. 40. So this maximum it could be is 60. So then the length would be 30 and 30. We can do it without a formula, can't we? Now, how do we turn what we're doing into a formula? This is tricky. This is the hard part. This is thinking beyond regular math. So basically what I want is I want a formula that gives me the formula for length with a width in it. What's the maximum we can have? Isn't that the maximum? What do we have to subtract from it? How many W's? 2 of them. Well, let's see if that works. Let's just see if that works. Let's pretend, let's go back to the first one. The width is 10, right? So 10, 10, 40, and 40. Is that right? Because that equals 100. Let's try it. So 2 times 10 is 20. 100 subtract 20 is 80. Oh, shoot, that didn't work. We want it to be what? 40. Well, how do we get from 80 to 40? No, subtract. Divide by 2. Isn't there 2 sides? Let's see if that works. Try it again. Let's pretend the width is 10. 10 and 10, right, should be 40 and 40. Let's see if the length of ours starts to 40. 2 times 10 is 20. 100 minus 20 is 80. 80 divided by 2 is 40. It works. Let's try it with the other one. 20 and 20 and 30 and 30, right? Is that correct? So 2 times 20 is 40. 100 minus 40 is 60. Divided by 2 is 30. Does it work? Okay. So what we've done is we've now taken L, and what have we replaced it with? W. Can we reduce that, by the way? If you're reducing that, 2 has to come out of not just 1, but both. So what is it when we do this? 50 minus W. Beautiful. Okay. So what value is width? What value? What letter? W. What letter or equation is length? 50 minus W. Now, we know that. How do we find the area? Length times width. Is that correct? Okay, so let's do this. Oops. So area, right, again, equals length times width. So what's the length? What's the length? 50 minus W. And what's the width? W. Oh, wow, okay, that's kind of cool. What can you do with that now? No, not FOIL it. FOIL it backwards. Expand it. Expand it. Basically, distribute that W, couldn't you? Basically, what you're trying to do is you're trying to turn it into standard form, right? An x squared, an x, and some number, if you can get that. So if you remember, distributive property is this, right? Is that correct? Yeah. Okay, so area equals negative W squared plus 50W. Is that correct? I just rearranged it, right? I put my W squares first. Okay, think about this for a minute. What we're trying to find is this is actually a parabola. If you graph this out, if we did it as, remember what were the numbers, 10 and 40, 20 and 30, right? If we kept plotting those out, we'd actually get a parabola. In this case, we're trying to find the maximum value of the parabola because we want to know the maximum area, right? So if we have it in standard form, can we find the vertex? How do we find the vertex? Which is which formula? Negative b over 2a. If you find that, will you find the x value of the vertex? Then could you plug it in and find the y value of the vertex? Yes, you could. Okay, so let's do this. I'll quit your yawning over there. So x equals negative b over 2a. Whoops, sorry, let me actually write that so you can read it. Negative b over 2a. Okay, what's negative b? Careful. Negative 50 over 2 times negative 1. Which actually makes sense because you're going to have a negative divided by a negative because don't we want the length to be positive? Yeah, I mean, you can tell if it's working right away. Negative 50 divided by negative 2 is 25. Okay. Now, that's the x value of the vertex. How do we find the y value of the vertex? Take it and plug it in. Yeah, okay. This is not a Glade commercial. So area equals negative w squared plus 50w. There's the original equation. Wherever I see a w, what am I replacing it with? 25. Area equals negative 25 squared plus 50 times 25. Okay, 25 squared is 625. So area equals negative 625 plus 1250? No, what is? What's 50 times 25? 1250. Negative 625 plus 1250 gives you, what is it? Oh, well, that makes sense. 620, positive, right? Yeah. Well, you've done all this work. But some of you will be looking at this and going, well, what the heck did we just figure out, right? You often get that, right? You do the math, but you don't understand what you've actually found. No, you can't be okay with that because math is about moving beyond that. It's like, man, what did you do? Think about this, what we've actually found. We actually, if you sketch this out, right, and you'd have a graph and it's, what is it, 25, 625. So it's probably a parabola, right? Looks up, my board is way off, but let me try that again. Let me try this down here so we can actually see it. So we have an x and a y, right? Probably something like this. So this point right here is 25, 625. Isn't that what it is? What the heck does that mean? because because we're finding area. We're trying to find the max. Okay, hang on a sec. We're trying to find the dimensions of this pen that gives us the maximum amount of area. So some of the calculations when we went back here, when we looked at the original, were, hey, if the width was 10, the length would be 40, right? Is that correct? If the width was 20, the length would be 30. We're trying to find the dimensions of the length and the width, that when we put them in a combination, when we multiply them together, it gives us the maximum area for these poor animals, right? Or students, right? Good point. We put the students in the case, right? So in this case, where did we just find out? What is our width going to be? 25. So if our width is 25, what's our length? No. We only have 100 meters of fencing. The length couldn't be 625.
Oh, it was. You put through.
Okay, so hang on. So the length is 25. What is that? Sorry, the width is 25. What does that make the length? 25. Because how much do we have in total? 100. So 25 by 25 by 25 by 25. Is that 100?
Yes.
So this is not a rectangle, but it's a square. And if you go 25 by 25, what is the maximum area for this pen? 625 meters squared. That's what you just figured out. Okay, so basically, let's write something down. This is a square. Right? The square is, if we draw it out, 25 by 25, and the area is 625 meters squared. Did any of you do questions like this in grade 10 pre-cal applied? Okay. Well, are any of you taking applied at all? Anybody taking 11 applied at all? If you did this in applied math, you'd actually create a table of values, put it in your calculator, and it would graph this out. It would look like a parabola. Well, you want to see? I'll show you. Just so you can see what it looks like. What is this? Y equals...
So is this because we're doing this in algebraic way, pre-cal?
Yeah.
Okay, because everyone's all like, why is there graphing in pre-cal?
There's a bit. So what was the formula? Negative, what was it? Negative x squared, negative x squared plus 50 x. I'll have to set my windows because I know my x value's got to be, my x max has to be somewhere, where was the middle, 25? So let's set it to 60. Our y max has to be somewhere over 625, so 700. Let's see what it looks like. And there it is right there. There's our problem. Negative, well, you could do 0 to 60 if you want, and 0 to 700. Because we only want, guys, do we want everything in quadrant 1? Yes, you can't have negative distance, you can't have negative area. Let's think about it. Can you have negative distance? No, the fence going in a different direction, still going a direction. Still positive, distant. You can't have negative time, you can't have negative distance. Get used to it. It's not changing. Okay, so now let's look here. Let me, how do you do the trace button here? Hang on. No, let's go here. Trace. Okay, so here, let's look at some of the values. This is what you were asking about. So for instance, we said x is 10, right? So the y value would be 40. What's 10 times 40? 400. Isn't that correct? I know it's not exact because I'm just doing a trace here. Is that 400? What did we say? X was 20, right? Let's try to find 20 here. There's 20. 20 and 30 and 30. What's 20 times 30? 600. Do you see how this actually works? Until we get to the maximum value, which was there. Now, it's interesting we have another side to this, because if x was 30, what if the width was 30? The length would now be 20, which is still 600, right? It's basically the opposite, right? The length and the width have reversed themselves. But the area is still the same, because when you multiply 20 times 30, it's the same as 30 by 20. Isn't that correct? And what we're looking for is we're looking for the vertex in this case, the max. So if we wanted to find the max, see, this is how you can check with the calculator. Left bound. We'll do the right bound. Give me a sec here.
How did you do that again?
Second trace. That will give you the calc, and then go to maximum. Yes, and it should give us, if we did it correctly. Now, I know it says 24.9999. What is that? 25. The calculator sometimes rounds. It does weird things sometimes. And what's the maximum area? 625. It's cool. You can really check with your calculator once you get the hang of it. But mathematically, you have to know how to do this. Okay, let me give you the questions, and then tomorrow will be a work class. But the questions I want you to do, what page? What are we on, 3.2? So page 174. Questions 1 to 9 at least. You know that already because I'll always give you all the practices to do. 174. What did we do here? Page 174. So 1 to 9 for starters. 1 to 9. And then let me give you, two. And now let's do this one. I'm going to give you question 12. I'm going to give you 10 and 12. Now, here's the deal with 12, though. 12 is a calculator question. So if you don't have a calculator, I will show you tomorrow. We'll go over to the computers on the side of there, and I'll show you how to do it. Because it's useful to know, because you might be able to use these, well, you'll definitely use these calculators, these TI Inspires in grade 12. We have a class set of them. Well, the color graphing calculators is phenomenal.
How much do you want those cost?
Like $200. Anyways, so 1 to 9, 10, and 12. And like I said, we'll do that tomorrow. Hang on. Yes, you'll give it to me. That's it. That's it.